Hello and Assalamu alaikum. How are you all students? I'm Abdul Rashid, your teacher of mathematics. In today's lecture, we will be discussing about intersection, its operation in sets. So intersection we will be doing with the help of using Venn diagrams. As you all are aware that we have been using Venn diagrams to represent sets, and we also show different operations using Venn diagram. So in today's lecture, we will be doing the operation of intersection using Venn diagrams. Um, so it is advised to all of you that you must watch this video till the end. If you skip this video, you may not understand the whole lecture properly. So it's advised to you to watch this video up to the end. Okay, so as you know, Venn diagram, we have been already discussing this Venn diagram. We have understood the lectures regarding the different types of Venn diagrams, like overlapping sets and subsets, and then disjoint sets. So we have three different types of Venn diagrams that we represent most of the sets by using all these three types. And we have also done the operation of union in previous lecture, in which we have solved problems regarding union. Today, in today's lecture of intersection, we will be using Venn diagrams to show how we can do the operation of intersection. So we will be using some kind of examples to understand the operation of intersection using Venn diagrams. Okay, so let's go. For example, I have two sets, like uh, for example, I have, if this is a question, the question will be like this: if a is equal to 1 2 3 and b is equal to it's like for example, it's a 4 5 and 6, then find a intersection b and also show the result by using Venn diagrams. Okay, using Venn diagram. Okay, so this is kind of question that we are discussing today. Before going to draw the Venn diagram, you must be aware that if these are the two sets, this is A and this is B, which kind of Venn diagram we will be using for these two sets. Either it will be a disjoint one, or it is a overlapping, or it's a subset. So here we see this is set A 1 2 3 and B is 4 5 6. So it's kind of, these two are very different sets because the elements of in this set A are not the same as in set of B. Hence these two are disjoint sets. So we may draw the Venn diagram according to these two sets, for example. So which ways will be which kind of Venn diagram we use to show these two sets. That will be like, we have this universal set that we can represent by using a rectangle, and then we have set A. So it's A, I will write these two elements inside this A set. And then we have B, I may write this B inside, I have 4 5 and 6. So what will be the intersection? Intersection is actually the result, which means all those common elements which are in set A and set B, that is our answer. But there are no such common elements, like A is 1 2 3 and B is 4 5 6. So the intersection is null set. Okay? Intersection is null set. So there is nothing common between A and B. If we do this manually, like as we always do, For example, this is same as like A intersection B. I will write the elements of A, which is 1 2 3, and the elements of B, which are 4 5 6. So there's nothing common between these two sets, hence we have the answer null set. We may write this as also like this symbol. So in intersection B, when these two sets are disjoint, when these sets are disjoint, we will not shade any area. So this is the our answer for disjoint sets. Now we will be doing intersection for two overlapping sets. Like now in another example I will be taking example number 2. If C, which is another set, that is 2 3 4 5, and we have D set, which is like um, 4 and 5 6 and 7. So these, now before going to draw the Venn diagram, you must be aware of these two sets, that which kind of these sets are. Either they are overlapping or disjoint or subsets. So here we see that there is something common between this set C and this set D. So we will draw a Venn diagram accordingly, and that Venn diagram will be of overlapping sets. So this is universal set that I represent with like a rectangle. So these are for overlapping sets. This is kind of overlapping. So the main difference between overlapping and a disjoint is that disjoints are very different. They are very far away from each other, but in overlapping, these two sets are like they are very close to each other. And if you hide this portion, this will may look like that the elements are wholly in A. When you hide this parts, you may see that the sets are in the all elements are in set B. So this region is very common. This is the region which shows the common elements. That means this 4 5, and here is also 4 5. We will write this 4 5 here, because these are common between these two sets, and these 2 and 3, they are only in set C. So sorry, I have written here A, this is C, and this is D. So all the remaining elements which are not common, we will write these two here, 2 3. And then we have D set. In D, 4 5 is in between, because this is common. 4 5 are common elements in C and D. The remaining elements, that are 6 and 7, that only are the part of, they are not in both. So we will write 6 7 here. Now in intersection, if you do this like we always do A intersection B, so we will write, sorry, not A intersection B is, I'm sorry, I'm always writing A and B. Okay, so this is C and D. Now we have C, that is 2 3 4 5, and then intersection we have D, which is 4 5 and 6 7. And what will be the intersection of these two sets? Intersection means the elements which are common in both sets, like 4 is present in C, and 4 is also in D, and 5 is present in C, and 5 is also present in D. So we write 4 and 5 here. This is our answer. So this is our answer. Now in this case, when we go to this side in Venn diagrams, we see that our answer is 4 5. So what we will do, we will shade this region in which we have these common elements. So this part, this common part, shows C intersection D, which is 4 comma 5. Or we may also show that the portion which is shaded like this is our answer. Which is shaded like this is our answer. So that's all about intersection of two sets which are overlapping. all right, overlapping sets can be drawn like this way. This is the example of disjoint says we have not shaded anything here because the answer is null set. So when you have a set which is not shaded and it says that you find the intersection, you conclude that if the intersection is null set, you will not shade any of these sets. Okay, so now we will take the third example, which is of subset. For example, I have a set like if a, I'm not writing a, for example, as I have a set which is e is equal to 1 2 3, and then we have another set which is f. For example, it is f is like 1 2 3 4 5. Okay, so now here you see that this set and this set, this whole set is contained in f. That means this one is inside this bigger set. The total set, all the elements of e are present in f, so hence this one is a subset of this set. So what we will do actually, we will draw Venn diagram which will look like this way. So first of all, we will draw our universal set which is a rectangle. Then we will draw our smaller set which is E. This one is E. So E has 1 2 3 in it, and then we have F. F is the bigger one, but F contains E. That means this whole E is inside the F, and F is also bigger than E. So what we will write? We will not write 1 2 3 again in this F, because when E is inside F, that means 1 2 3 are also present in F. We will write rest of the elements which are 4 and 5. For example, this is like if I'm recording this video in a room of my college. That means if I talk about college, that means I'm also talking about that room which is inside the college. I will not separately mention that room. So this is that small room, and this is the whole building. So when we talk about this building, that means this room is also present inside that. Hence we will not write the elements 1 2 3 again in this F set, because this whole is concerned in F. Hence the E is also in F. So when we do the intersection, here we go. If we do this manually, like E intersection F, so what we will get actually, it's a 1 2 3 and then intersection F, which is 1 2 3 4 5, and the result is so common elements. So here you see the common is 1 and then 2 and then 3. These are common elements, so we will write this 1 2 3. Okay, so this is the intersection of E and F. This is our answer. Now we see where is that answer included in this question. Here we see that 1 2 3 is inside E, so we will shade this whole E. In other words, if you generalize this problem, this means E intersection F, when E is a subset of F. Okay, so when E is a subset of F, when E is contained or subset is contained in F. Okay, then E intersection F will be E, equal to E, so the smaller set. Okay, so this is our answer, E intersection F, which is equal to 1 2 3, and we may say that this is shaded like in this box, which is shaded like this way. This is our answer. And now after this, I hope you have understood. For example, now if I'm going to generalize this concept of A intersection B. A intersection B is actually the answer which says that x, such that x belongs to A, and this means and, and is like and x belongs to, x is that x belongs to A and x belongs to B. So this is the generalization of A intersection B. Hence, we will write that this means that we write those answers in a we will write those elements in our answer which are in A and which are in B. We will not write those elements which are in A or in B. So we will write all those elements which are in A and in B. That means which are in A and B, which are in both sets. We will write those as the answer. So I hope this is kind of helpful to you. We talked about the intersection of two sets using Venn diagram. So we have tried to solve these problems with the help of examples. And the first example is if we have two disjoint sets, then we will we will represent these two sets like this, and this is the intersection of two disjoint sets. And then we have a second example which says if we have two sets which are overlapping, which have something in common, and we will draw the Venn diagram for these two sets like this way. This is the common elements place where we write the common elements, and hence we have shaded this region. That means this part is our answer. These elements which are not shaded are not included in our answer. And we have took the third example which says if I have a smaller set and that set is contained in the bigger one, and then we can show their intersection by using Venn diagram like this way. Hence in this situation, if E is smaller than F and E is a subset of F, the answer in intersection will always come the smaller set, this one. And in generalization, if you want to know what A intersection B is, this shows that in our answer, this talks about the answer of the question of the intersection. This shows that if you have A intersection B, that means okay, you will choose those elements in your answer that are in A and that are in B. So this is all about today's lecture. I hope you have understood this. Keep me in your prayers. Wish you good luck. Goodbye and see you in the next lecture. Thank you very much. Bye.